Hi everyone! Today we're going to talk about triangle congruence. So quick review. If two triangles have three pairs of congruent corresponding angles and three pairs of congruent corresponding sides, then we know that the triangles are congruent. So for example, if we know that angle A equals angle X and angle B is congruent to angle Y and angle C is congruent to angle Z, and if we know that line segment AB is congruent to line segment XY, and line segment AC is congruent to line segment XZ, and we know that line segment BC is congruent to YZ. So there's all three pairs of angles and all three pairs of sides. Then we know that the triangles are congruent. That's 6 parts that we have to know. However, there are some shortcuts that we're going to talk about today. So you don't need to know all 6 of them, all 3 sides and all 3 angles, to know that the triangles are congruent. There's some shortcuts where you only actually have to know 3 parts, and we're going to talk about those shortcuts today. Okay, so first let's just think about the different combinations there could be of 3 parts of a triangle. So of the 6 parts, we have 3 angles and 3 sides. Let's think about what 3 parts could look like. You could just be thinking about 3 sides, right? The 3 pairs of corresponding sides of 2 triangles, or we could be thinking about the 3 angles. Let's mark that on our picture. So if it was the 3 sides, we'd be talking about knowing that this side is congruent to this side, and knowing that this side is congruent to this side, and then knowing that this side is congruent to this side. For 3 angles, we could be talking about this angle being congruent to this angle being congruent to this angle, and this angle being congruent to that angle. So obviously that's the pretty simple three sides or 3 angles. But another combination could be 2 angles and 1 side. Or another combination could be 2 sides and 1 angle. So those are the different combinations of 3. Let's talk about these a little more specifically. If we talked about 2 angles and 1 side, let's look at what this could look like in the picture. If we have 2 angles, it could be this angle here corresponding to that angle there. And then here's another angle. So maybe this angle over here and this angle here. But for the side, let's say it's the side right between those. Let's say it's this side right between the 2 angles, which would be a little bit different than if we had, let's do the same angles we had a second ago. And then this time, let's say that the side isn't a side right between them, but instead it's maybe this side up here. That's corresponding. So we're going to talk about how these 2 are different. This set, this one right here, because the side is right between those 2 angles, we call that an included side. It's 2 angles with an included side. Right, because it's right directly in between 2 angles. It's almost like where those angles, like physically connecting them. Where in the second example, this would be called a non-included side because it's not physically connecting those 2 angles. And it could have been that side, or also it could have been this other pair of sides over here. Both of them would be a non-included side because it's not the side that's connecting the 2 angles. Okay, let's move on to the combination of having 2 sides and 1 angle. So let's just pick 2 sides at first. Let's say we're talking about this pair of corresponding sides and then this pair of corresponding sides. And we'll do the same thing down here. We'll do the same sets of sides. It doesn't matter which pairs I'm picking. I'm just picking 2 pairs of sides. And then for the for the angle, it could either be the included angle, meaning it could be this angle where those sides are physically coming together. And again, we'll label this. This is called an included angle. Or it could be a different angle. Let's say we're talking about this angle up here. This would be a non-included angle. Okay, so each of these different combinations that we came up with, and there's 6 combinations, they all have a name, and we're going to name each of them right now. So the top 2 are the easiest. So if we're talking about the 3 sides, we call this side, side, side. Pretty simple. If we're talking about 3 angles, we call this angle, angle, angle. If we're talking about 2 angles and an included side, if you look at the order here of like how it's shown in the picture, it goes angle, then a side, and then an angle. So we're going to call this one angle, side, angle, which is different than the one below it where it's a non-included angle, or sorry, a non-included side, where this would be called angle, angle, side. You could also call it side, angle, angle. It just seems like this name gets used more, but you could reverse it and it would be fine. So again, if you're just looking at like the order of how it is in the diagram, then you're seeing that we've got this angle and then a side right in between and then this angle. So it goes angle, side, angle here. Where down here, we're seeing an angle and then an angle right next to it and then the side, right? That side is not in between them. It's not the side that connects them. So you could either call it side, angle, angle, or angle, angle, side. Let's look at how we're going to name the ones on the right. When we have 2 pairs of sides and an angle, we would call these, and where it's an included angle, this would be side, angle, side. And again, you can see because that angle is directly in between, it's right in between the 2 angles. Or sorry, it's right in between the 2 sides that we marked as corresponding. It's literally connecting them. That's why we're putting the A right in the middle to show that it's an included angle. And then for the bottom one, because it's not included, we go side, side, angle. Now, you could reverse this, but you can see very quickly why we don't typically reverse that one. We're going to typically write it this way as SSA, because this one can, cause a little bit of confusion with some people. So we don't want to use it that way. We're going to use it in the side, side, angle way. All right, so make sure you understand where these different letter grouping names are coming from. Like where I think side, 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 and angle, angle, angle are pretty self-explanatory. But if you don't understand the difference between angle, side, angle, and angle, angle, side, please make sure you ask me that question. Or if you don't understand the difference between side, angle, side, and side, side, angle, make sure you ask me that. But you're going to get to practice that in your homework tonight. All right, so here's another look at the 6 combinations that we talked about on the previous slide. So you can see where we started off with side, 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 3 pairs of corresponding sides that are congruent, angle, 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 3 pairs of corresponding angles that are congruent. And then for the other 4, on the left, we've got the 2 that were 2 pairs of sides and 1 pair of angles, but make sure that you understand the difference again between side, angle, side, and side, side, angle. You'll notice that on the one with the angle in the middle, the side, angle, side, that you've got physically this angle right here in between the 2 sides. And then same over here on this side. And then for the other one, this angle is not physically between them, right? It's over here. It's not the angle right here in between the 2 sides. That's the difference between side, angle, side, and side, side, angle. Same thing on the right side when we have 2 pairs of angles and 1 pair of sides. The angle, side, angle, the one that has the S in the middle, is because it has this included side. This side is physically in between those 2 angles. Where on the bottom one, the side that's being marked is not physically between them. It's not connecting the 2 angles. So you can see here's the other side, right? That's the one that would be included, but that's not the one that's being marked. And that's why it's side, angle, angle, or angle, angle, side instead of the side in the middle. So again, hopefully that makes sense. Okay, so we have these 6 combinations of 3 parts of our triangles. And not all of these are actually shortcuts that work. And when I say work, what I mean by that is not all of these shortcuts can tell us that we actually have congruent triangles. Of these 6 combinations, there are 4 that work and 2 that don't. What I mean by this is if I gave you 2 triangles and I told you, for example, that all 3 sides of one triangle are congruent to all 3 sides of the other triangle, is that enough information to know if the triangles are congruent or not? Or for the second one, if I gave you 3 angles of one triangle that are congruent to 3 angles in another triangle, is that enough information to know that they're congruent? So again, of these 6, 4 of them, it is enough information. It's a valid shortcut that we can use to know that 2 triangles are congruent. But there's 2 that don't work. Hopefully, there's one of them that you can see that's very obvious that it does not work. Do you see which one it is? Which one can you tell is a pretty obvious not going to work? Okay, it's this one. Angle, angle, angle is not going to work because, let me just draw you a very quick example. Let's say that I have this triangle and I have 90 degrees over here. Let's say a 30-degree angle over here and a 60-degree angle there. Okay, let's draw another triangle. Let's say we have 90 degrees here, 60 degrees here, and a 30-degree angle over here. These triangles are clearly not congruent, right? We have 3 congruent angles, but the triangles are still not the same. So this is one of the ones that does not work. Angle, angle, angle is not a valid shortcut to proving that 2 triangles are congruent. There's one more that's a little harder to tell, and so I'm just going to tell you which one it is. But it's easy to remember because it's the one that if you spell it backwards, it spells a bad word. So this is the other one that does not work. So we're going to kick that to the side like a donkey would kick something. You can see why I'm going to use that reference there. We're going to have the donkey kick it to the side, and that one's not going to work. So the other ones are all valid shortcuts. So if I gave you 2 triangles and only gave you the 3 pairs mentioned in those 4, you would know that the triangles are congruent. Okay, just to tie this up, only 4 of the 6 possibilities will guarantee that the 2 triangles are congruent, and they are side, 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 angle, side, angle, side, angle, and angle, angle, side. That last one, of course, you could write as side, angle, angle. And then the 2 that do not work are angle, 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 and side, side, angle. So again, this one doesn't work because you can have 2 triangles with 3 of the same angle measurements, but they're different sizes. Like the side lengths are different. Like you could blow one up or shrink one down. And then this one, for right now, just know that it doesn't work because it spells the bad word. But I'm going to show you an example down here, just kind of talk about a little bit why. So this picture is a little bit hard to see what's going on, but I'm hoping some of you can visualize this to see why SSA doesn't work. So if you look at the triangle on the left right here, we have triangle ABC, and we've got marked these 3 parts. We have the side length from A to B, that's one of our sides. We have the side length from B to C, that's one of our sides. And then here is a non-included angle of angle A. That's one of our angles. So you can see that it's trying to show the shortcut of side, side, angle. Okay, what happens though is if you take those same exact measurements and you take this side BC and you swing it out this way, like if you just take that, if you can imagine physically picking up that length and moving it to the right, I can make another triangle with these same exact measurements. See how I still have line segment BC. I still have line segment AB. This is the same exact lengths as we had over here, AB and BC. I still have angle A, but it's a different triangle. These 2 triangles are not congruent, but yet they have those same 3 pairs of corresponding parts. They have the same set of side, side, angle, but the 2 triangles are not congruent. So because of that, that's why SSA doesn't work. Okay, take a second and now draw an example here to show why AAA doesn't work. Remember, I showed you that earlier. I want you to draw your own. Here's just one example of what this could look like. You could draw an equilateral triangle where all the angle measures are the same at 60 degrees. So if I have a triangle where all 3 angles are the same, and then I have another triangle where all 3 angles are the same, all 60 degrees. So there's one example of why AAA doesn't work. It doesn't matter what kind of triangles you draw. You could just draw a random triangle, right? And then just make another triangle that has the same angle measures, but is clearly bigger than that. So let's say maybe this is 120 degrees. And let's make this one 10 degrees. And that leaves us with 50 degrees for over here. So these two triangles have the same angle measurements, but they're clearly not congruent because one is larger than the other.